So hello, I'm Stefan Di Vito, product definer and security expert for the Secure Authenticator product line of analog devices. And I want today to present our security solutions for cybersecurity in vehicles. So modern vehicles are now made of a lot of electronic content, where it's like a network of sensors, actuators, all connected to embedded computers, the ECUs, which are themselves somehow connected to internet or in order to perform like infotainment applications and also to communicate with the infrastructures and the smart roads infrastructures in a way. So all of this creates a lot of cyber security vulnerabilities because of this interconnection of smart systems. So with ADI, we provide solutions in order to secure the network of components within the car, and especially we provide solutions to secure the endpoints. So endpoints in the car network are like the sensors for, let's say, driving assistance. So that could be the cameras and the LiDARs, which are to be safe and secure. So the cars, they have a lot of valuable components, especially premium cars. So the front light modules, the steering wheels, they might have to be protected as well against counterfeiting and also against robbery, because they might just get stolen and put into another car. So the security solutions ADI provides are really designed to make sure car parts, those endpoints, those valuable sensors, whatever, are authentic from the original OEM manufacturer, and also prevent the robbery and also secure the communication of those parts within the car to the ECUs to make sure the data streams are not, let's say, hacked by some external entity or maybe some hardware addition to the car that would modify the data traffic within the car. So the solutions we provide are inherited from secure microcontrollers for financial transactions. So we have a lot of security features in some tiny chips. Those tiny chips are designed to be attached to the endpoints of the car. So for example, we have a demonstration here where we will authenticate a camera sensor. So the part is integrated into the camera, and on the ECU side, so the computer that controls the camera, we also have to implement some addition to perform the authentication of the camera and make sure the camera is really from the original manufacturer, and also that the camera is also correctly associated to the car and it's not just a replacement which has been done in an unsafe manner, I would say. So in addition to authentication and also security of the data traffic between sensors and embedded computers of the car, we provide a life cycle security because supply chain is also a big concern. Security is not only about security during operation of the system, it's also security during the manufacturing, during the acquisition and purchasing of parts, and also afterlife, when the part is discarded. We have to make it secure by erasing all important information from the car to avoid further reverse engineering by attackers. So these solutions also provide a mean to secure the part throughout the life cycle, from manufacturing to end of life. So here we are displaying the internal architecture of the authentication chip that goes into those car endpoints. So those chips are named DS28C40 or A40, depending on the variant. And they feature a number of functions. So there is a command function block, which is designed to provide simple cryptographic functions to the system in order to perform the authentication of the automotive sensor or endpoint. It also has a highly secure storage to store the authentication keys, and those keys are really the core of the security of the system. Simply because if the key is copied, then an attacker can clone the device infinitely and then make some potentially unsafe parts for this car. So this storage technology is inherited from the financial terminals, as I explained, and yeah, it's highly secure. Cryptographic engines to perform the authentication fast and reliably. So this is what we put into this tiny 3x3 millimeters chip. And for the embedded computer, the ECU side, either the authentication protocol is implemented in software, so we provide software to implement that authentication and make the system operational, or we can also provide an additional chip that would perform the authentication. So the microcontroller of the embedded computer would simply delegate the authentication process to that specific part. So overall, this solution is covering the authentication. And now I would like to show you a little bit more in details this authentication process in a simple way, because crypto is, it's not easy, but the principle is kind of understandable. So here we have a dashboard of a car, so that represents the embedded computer of the car, one of them. And we connect this computer to a camera sensor. So obviously we don't have the camera, it's simply the authentication chip. So that could be basically any car parts that sit here. And for the purpose of the demo, we use this high-speed serial link, which is totally optional in this security scenario. And when I start the car here, the car is going to make sure the part is authentic. So for this, it's going to send a random number to the chip. And the chip is going to use its secret key stored in the secure memory in order to make a digital signature from that random number. And the result is sent back to the computer. The computer is also going to perform the same calculation with the supposed key value. And if there is a match at the end of the process, it means that the computer and the car part, they share the same secret key, which means the part is authentic. So that's the basic of the authentication process. And the key is safely stored in the chip. It's impossible to extract and copy, so that makes the entire part unclonable. So overall, the car makes sure that all the parts are authentic and are safe to use. They have not been robbed from another car, and also the overall security and safety of the car is guaranteed. Well, thank you for listening, and I hope you can visit our website to get more information about security solutions for automotive.